how to build a real enterprise network in GNS3 using FortiGate firewall. This network will compose of wide area network segment, the local area network segment, and the demilitarized zone, so that in modern enterprise networks, proper segmentation and security control is a key area whereby it is used to protect critical assets while allowing users and services to communicate efficiently. So that in this lab, we shall build the realistic enterprise network composing of WAN, then LAN, and DMZ, that is the militarized zone. So that the enterprise network is categorized in terms of zones, whereby the militarized zone consists of servers, public facing, like servers facing the internet, and these servers might be email, FTP, and others. So the goal to use this zoning is that it helps the organization to understand and also separate internal users from public-facing services while maintaining secure access to the internet and business application. So you find that users in such kind of enterprise network do not just directly connect to the internet, and even though they do so, there is a shield, there is a firewall. Access their requests are passed through the firewall, so that the firewall decides. This is the architecture for enterprise network. It composed of wide area network. This is the connection to the internet or external service provider. It serves as the entry and the exit point for the traffic. So this one is untrusted zone, the wide area network. 2, we've got LAN, local area network. The LAN contains internal users, workstations, printers, and company resources. This network is protected from direct internet access by a firewall and is considered a trusted security zone. The next zone is that demilitarized zone. So this is a dedicated zone segment within the network that is used to host public-facing services such as web servers, mail servers, application servers. Also, generally, in majority of the organization, you find that the data center or the server room or the server farm is under this segment, this section here, the militarized zone. So there are some benefits of this zoning or network segmentation zones. So it improves security. How? It enables internal users are created a secure tunnel through which they connect to the internet. It's not just as a direct that way. So it reduces the attack surface. Before the threat actor from the untrusted area network, that is the wide area network, reaches the LAN, there is a firewall in between, and there is also the militarized zone. The servers are separated from the local area network. So it controls traffic, you can see. So traffic from LAN is controlled on how it will reach to wide area network and also DMZ. So it provides an easier monitoring and troubleshooting. So these are the things that you should understand. These are the benefits of using zones in the network. It provides improved security, reduced attack services, better traffic control, easier monitoring and troubleshooting. It also promotes compliance within the enterprise security standards. So that the FortiGate in this architecture serves as the central gateway between the zones. It sits at the middle of the zones between the demilitarized zone, wide area network, zone, then local area network zone. So in this lab, I'm going to configure the WAN interface, the interface facing the internet. Also, I'm going to configure the LAN interface, and in my section here, you can see the LAN interface is consisting of two LANs. I have LAN 1 here, and then LAN 2. You see, these two departments or local area networks are under this LAN. So this is this section. This section is what I'm calling the wide area network. This is untrusted zone. That is the zone facing the internet. Then DMZ, demilitarized zone. This is the segment or a zone onto which hosts or servers are hosted. You can see I have Ubuntu server here. This one is serving as a FTP server, mail server. You see? Then I have DC here. These are Windows server, Windows 2022 server. It is acting as a primary domain controller. You see? And this is I have a PC here. These are admin. So this is the person sitting at the data center for control. You can see this is the topology that I have created. This is the topology that I have created to ensure that I achieve this particular lab. So in this case, so I'm going to configure the interface, also provide static routing. Static routing in a sense that I'm going to manually define how traffic flows from the LAN to the wide area network or to the internet or to the demilitarized zone. That is what I mean here by static routing. Also, there are benefits to do with this. So like internet access for LAN users, it provides external access to published services. This section here, you see, this is the DMZ. Proper packet forwarding, it is true. So this is the best, the best reasons or significance of having static routing. It helps you to define which internal user will access which service at what particular time. So routing can be verified using ping and traceroute commands from both LAN and DMZ. So after this, I also achieve it through use of firewall policy. And in this case, firewall policy, this is how I will define the traffic. I'm going to allow traffic from LAN to reach the wide area network. I'm also going to allow LAN to reach the DMZ. I'm going to allow the internet to access the DMZ because these servers here must access the internet. I'm also going to access the wide area network to access the LAN. So, like, you need to understand there is what we call priority. Let me go back to my topology here. So this section, the demilitarized zone, its priority is 50 to somewhere there 80. Then the LAN is 100. Then the WAN section is 0. So traffic from higher priority has that significance to flow to the zone whose priority is low. So for example, LAN, traffic from LAN can go to internet, can go to DMZ because LAN happens to have higher priority than any of these two zones. You see? Then traffic from DMZ can reach the WAN without implicitly. But traffic from WAN to any of these two sections, this DMZ and this LAN, must be explicitly defined because this one has a lower security level. So that's what you should understand. So I'm going to configure on this particular topology. You can see I have already labeled and decorated my topology. So I have configured this admin here to be able to access this particular FortiGate, being our central gateway here. It is the one that is going to define how traffic flows and how these interfaces are configured. The wide area network section is a DHCP zone. There is no any IP that I'm going to configure on this port 1 here. Port 1 is going to receive IP address automatically from the internet. So port 2 is facing the LAN, and remember there is also no port that I'm going to configure on this, no IP address that I'm going to configure on port 2, because you find that port 2 is acting as the main port, providing anchorage to LAN 1 and LAN 2, you see. So it means this, I'm going to create sub interface on this port 2 to support LAN 1 and LAN 2. So from there, the demilitarized zone, this IP address are going to be statically assigned because they are hosting shared services. So let me go back to my FortiGate. You can see port 1 is facing the internet, port 2 is facing the LAN, then port 3. So 11 is, this subnet is for DMZ, and then 13 is for LAN 10, then 14. So let me go back to FortiGate. This is my FortiGate. I have accessed it. You can see. Maybe I can go back. I'm accessing it using this IP address. You see, it's at the admin who has logged in. So on this, just a quick one, I'll go to the network section, then interfaces. So on the interfaces, this is where I'm going to assign IP addresses on the interface. You can see that port 1 has gotten an IP address. This is a public IP address. This is a public IP address that has been given or assigned by the NAT or the internet. So port 2, I'm going to configure port 2. You see, port 2 is supporting 2 networks, so port 2 will serve as the VLAN. That's what you should know. So port 3 is serving the DMZ. So this is DMZ. Then the role, this is then IP address 192.168.11.1/24. So after there, and then you enable ping, then save. Then okay. So port 3 configured. This is the one that is facing the DMZ. On port 2, I'm not going to create anything here. What I'm going to do is just to create an interface. So specific VLANs. So this is VLAN 10 or LAN 1. LAN 1. Then LAN 1 still. So the interface, this is port 2. This is the main interface. It is supporting 802.1q. Then LAN ID, this is 10. Then role is LAN. So that's how you create that. Then you assign the first IP address in the segment onto which that VLAN is. You see, I assigned the first IP address from this segment. So 13.1.24. So on this VLAN, on this sub interface, I'm going to enable the DHCP because to support users under this VLAN. So after there, it is created. When you go to under port 2, there is a plus sign there, meaning there is a sub interface that has been created. So I create another one, LAN 2 that way. Then the interface is port 2. Then the ID, don't forget ID because traffic will be based on this ID. Then the subnet is 14.124. Then after here, you enable the DHCP. You enable the DHCP and then okay. So I have finished configuring the interfaces. I have configured the demilitarized zone interface, also configured the sub interface on this main interface here. So currently I'm almost halfway, but what I'm going to do is to ensure that you understand every step that I'm moving. You see, this computer is statically assigned. All these things, all the servers here plus the admin have static IP. As you can see, I have appended the IP that is assigned to that particular machine. So next thing, I'm going to define traffic. I'm going to define how traffic flows now according to this guide here. You can see LAN to WAN. So when I say LAN to WAN, within my local area network, there are some sub-local area networks, LAN 1 and LAN 2. So I'm going to enable LAN 1 and LAN 2 to access the internet. Then I will also enable them to access the DMZ. So I'm going to create a lot of rules here. So I'm going to first of all allow this one to talk with this one to talk with this one, because computers here can communicate with each other but cannot communicate to this section, because this is going to serve as inter-LAN routing. So to do that, I'm going to the FortiGate firewall, then under policy and objects, LAN 1 to LAN 2. So that rule, it is going to define this one. This LAN 1 can communicate with this one. Remember, communication with all the nodes within this department communicate effectively. So I do this. The incoming interface where the traffic is coming is LAN 1, then outgoing is port 2, because you can find that when this one communicates with this one, this traffic has to reach to the firewall before it comes to LAN 2. So So from here, the source, I define the source. Destination. The source is LAN 1, then destination is LAN 2. Yes, you can see here. So that is it. Then from here, you enable all sessions. So this one, it means that LAN 1 can now communicate with LAN 2, you see, through port 2. So LAN 2 to LAN 1, incoming interface, outgoing port 2, then the source is LAN 2, the destination, service, all, accept, then all sessions, then lock. Let's try to verify that. First of all, let me enable to ensure, because I had configured these machines to get IP address automatic from the server. So just IP DHCP. Then once you see DORA, discover, offer, request, acknowledgement, it will give you it is saying it cannot get the IP address. So you will come on the interface, DHCP server enabled. You see, the problem is that I did not enable this section here. Should ping. So remember, I hope you've seen where the problem is. This computer here, it is struggling to get IP address automatically from the server here under its interface, because this port here, it's not configured as a trunk port. That's reason number 1. 2, deliberately I have not created VLANs on this switch. So I'm going to create VLANs here. LAN switch, so config terminal VLAN 10 name LAN 1 VLAN 20 name LAN 2. Then assign interfaces, interface range Ethernet, it should be Ethernet 01 up to 4. There is a problem, let me check this. Ethernet 0/3. So Ethernet 0/, let me delete this interface first to be able to give it Ethernet 01, Ethernet 01 up to Ethernet 03. Switch port access LAN 10, description LAN 1, exit, interface Ethernet 20 up to 4. There is a problem here. The problem, I'm forgetting the word range. Ethernet 20 up to 4. Ethernet 2. Switch port mode access. This is the long method. Switch port access VLAN 20, description LAN 2. After here, interface Ethernet 0/0, switch port mode trunk, switch port trunk encapsulation dot 1Q. So like it is in auto negotiation, so you have to choose the particular mode that you are going to use. Switch port mode trunk. Now you can see it is accepting switch port trunk allowed VLAN 10 20. Description trunk port for LAN 1 and LAN 2. and then copy write memory. So I have configured that. Now let me check IP DHCP. You see, it's accepting. So that I created that particular scenario just to make you learn how you can solve a problem. This is not just a mere lab that we just do and then things work suddenly. I just intentionally made things fail so that at least I can troubleshoot and let you know if you happen to be in that mess, how can you get out of it. So I had not configured VLANs and the trunk port, and that's why the computers were struggling to reach the DHCP server. So that is it. Now we can try, it will work. The moment you get DORA, it means that DHCP is successful. So let's ping 192.168.14.2. You see, it's pinging. Let me make it bigger. That is it. What about this section? It should also get IP address. You see, the DORA good. Let me ping 192.168.14.2. Okay, so I'm done with the LAN. Now let me allow traffic to reach the WAN. For example, you will come here. Let me create a static route. This is the gateway for the internet. You can see it has gotten the IP address to 49 automatic. So let it be dynamic. So in the case that a computer is not going to get the gateway, it is going to forward traffic to the internet. So let me show you how to create a route to the WAN. You come to the firewall policy. You create LAN 1 to 1. So incoming interface is LAN 1, outgoing interface port 1, all sessions. So port 1 is the one, then LAN 2, incoming, outgoing is the port 1, source. When I say all, I mean all nodes on that segment. Then destination, anything facing the one, it will be accessed. Then all service without restriction, then accept. Then after here you log all sessions. Then let's test. Ping. You see, it's pinging the internet. That's how we create the rules. You see, it has worked perfectly. So I have ensured that both LAN 1 can access the internet, LAN 2 can also access the internet, just by creating these rules here. I'm using the graphical user interface so that at least you can master. So after mastering, then you can move on the command line interface. As a network engineer, you should know. So these are the rules that are enabling this particular pinging to be successful. Like you see, port 1, LAN 1 to port 1. Port 1 is the WAN interface. Then LAN 2 here, still to port 1. So because my LAN is divided into two, LAN 1 and LAN 2. So that is it. You can see here I can be able to capture packets. Let me stop this one first. So let me ping. Make it bigger. Make it bigger for you to understand. I'm going so slowly so that at least you can get what I'm doing. So for example, in this topology here, this is the internet. And the internet, it means that I can access anything on the internet. For example, generally Google can be accessed, and Google, the DNS for Google is 8.8.8.8 or .4.2.2.4. Those are the DNS address, the domain name service addresses. So if I'm able to reach the wide area network, that's the internet, I can ping Google or whatsoever. So I'll come to this, then ping. For example, 111 is the DNS address for Cloudflare. You see, it's pinging successful. Ping 888. You see, it's still pinging. So I'll ping that way. Then I come to this section. Then on this, start packet capture. So you can see what is happening. Just a minute. You see, my Wireshark is now coming up, registering the interface, picking the specified interface to ensure that the packets captured are the correct ones. So you see here, for example, if I can pick this packet here, you can check, you can analyze the packet. For example, here, total length 84 bytes sent. You see the addresses, the source address. Now this packet is the one, the traffic was now coming from the internet to that particular LAN. Destination is this one, computer under LAN 2. You see, that's how you interpret packets. So when traffic is going, this computer will be the source, the internet will be the destination. When it will be coming back, the internet will be the source. So it will do so until you stop the packet capture. You see, it will give you the timelines, then the source, destination. So the source, it will keep on changing depending on the flow of packets. And this is the protocol. The protocol, you can see ISMP, SDP. So that is it. Let me stop the capture. So that is it. I have successfully configured the local area network to access the wide area network. So the next thing, I'm going to ensure that local area network access the demilitarized zone, because I told you earlier that traffic from a high priority zone moves to the lower priority zone without any hindrance. So in my case, this zone having a priority of 100, this zone having a priority of 50 or 70, then this zone having a priority of 0, traffic can comfortably flow from this zone, the higher zone, to the lower zone, but not vice versa. It cannot move from the lower zone to the higher zone, not unless you've explicitly created a rule to define what to allow and how. So traffic, now we've confirmed that it can flow from this section, both two LANs, to this. Now let me configure the one to the demilitarized zone. Don't forget to subscribe. Always subscribe at Netlabs Hub for more videos as we keep learning together. So let me create that rule to ensure that traffic from LAN 1 or LAN generally flows to the LAN 1 to the DMZ. So my incoming interface is that interface that is where the traffic is originating from. And in my case, I'm picking LAN 1. LAN 1 is just a sub interface bound on port 2. So incoming traffic, outgoing, I'm using port 3. Then the source, I will allow all of it. Destination, all of it. Then that way, after there, you log in session, then enable. There is a lot of rules here, but every rule has its role. LAN 2 to DMZ. Outgoing, port 3, destination, all, service, all. You can choose the service also. You can restrict maybe web access or the file. After there, log sessions. If I forget anything here, it's okay. You should also learn how to create these rules on the CLI. That one will give you an upper hand. So let's try. This is 192.168.11.10. So while here, can I ping ping 192.168.11.10? You see, it's pinging. So my traffic can also reach the demilitarized zone. So let me do so, then capture the traffic. So I will capture traffic on this interface. So traffic is coming from LAN 2 here up to this computer here in the data center. So let me quit that. You can see here, you can notice something. Let me just stop and explain. So here you can find 192.168.11.1. This is the gateway or the firewall interface facing the demilitarized zone. Then this is the computer. This computer 192.168.11.10/24. This is the computer. So traffic is flowing through the switch, through this main port here, through the firewall, then through port 3. So port 3 here is having the 192, is having this address 192.168.11.1/24. You can see it here. So that is the address, the gateway that is helping this traffic to flow from all this up to the destination here. So once it reaches here, because I'm doing continuous ping, it will come back. So now this one will be the source, then it will use the same gateway up to the destination here. That's what the packet here is giving me. The packet capture, you can see. So once it, for example here, once it goes out, now this is coming through, it comes through the gateway, then this one is going back, the traffic is going back. So it is coming from this IP here, this computer having this IP address through this gateway. So when this is the source, the gateway is the destination. So from the gateway, it will decide how it will get the final destination now. So that is it. So next thing, I'm going to explain something concerning how I have achieved this. So building an enterprise network is one of the key areas as a network engineer you should understand. So you see, traffic is flowing comfortably now because the power of defining this routing here. I have defined traffic to flow from LAN up to WAN. I have also defined how traffic should flow from LAN to DMZ, then WAN to DMZ. Traffic from WAN, that is the internet, to go to the DMZ. Remember, the wide area network is a zone with lower priority, 0. Then DMZ, the militarized zone, is having a priority of 50 to around 70 there. So this one, it should be explicitly guided. So from WAN to LAN, block direct access from the internet to internal to protect the system. So not unless in this section also you can just explicitly allow particular services but not all. Connectivity. So LAN users can access the internet. That's okay. You've seen that. LAN users can access the internet. Let me show you. Maybe so ping. Can it ping the host? You see, it's pinging Google. If you want to see that indeed it is working, you see I have just pinged the domain name for Google, and it has resolved to this IP. So meaning we are online, we can ping any site. So far as you can see, LAN can access the internet. Let's ping something here. It cannot resolve to that because this is private. You see, this is private. So Google is a public, is a public entity and has a public DNS. But for example, this is a website for a certain university here. It is not so that public. It is the one that is hosting that. So for public websites, it will work. You notice what? You notice it is coming from, this is the IP address assigned to the computer that is hosting the Google website. And remember, it is using this ICMP, Internet Control Message Protocol. Sequence is the number of the flows. As flow happens, as traffic flows happens, the sequence number increases. So time to leave, this is the time taken for a packet to find the destination. If not, once it decrements and reaches 0, the packet is dropped. So that's what you should notice about that. So according to this guide here, LAN users can access the internet. Also, LAN users can reach the DMZ service. So I can just still ping 192.168.11.10. That is the IP address for the admin. You see, it's working. So this is how you configure a real enterprise network anchored on those zones. And you see, in real scenario, you may find that this one is having sub layers. For example, you've got like maybe a big company that is having data centers across the continent or multiple continents. So in that scenario, they can bundle all those data centers or server farms into one zone. So you now relate, how can that be simulated? Also, when it comes to LAN now, it can be local area network or LAN network that are situated in different environments. You might have maybe a company is operating maybe 120 countries. 120 countries, it means those 120 networks. Different networks summed into one network environment. So that is where you will understand the power of firewall and all these particular things that I'm simulating here. So the internet here. So the internet, you can have more than one service provider just providing a service to you. So another thing I'm explaining to you here is how to troubleshoot this network. For example, when a node or a computer within local area network cannot ping the internet, first of all, if that computer is connected is having the network, check whether the computer is having the network. Once you verify that the network is connected, the computer is having the IP address, the cable is okay, those are the issues that you should check. Check the route. Is the route dynamically created or statically created? If statically, in large network, you may find that there are static routes and dynamic routes. If there is a conflict between the two, check on that. So if you cannot ping any of these zones, just narrow down to how the routes have been configured. Sometimes it can be a problem can be at a layer 1 or layer 2 issue. It means, when I say so, I mean maybe the cable is so loose, or the cable is not well crimped, or is loosely attached, or it is not connected to maybe the port, the Ethernet port is having issues, you see. So if you confirm layer 1, layer 2, there is no issue, then upgrade to layer 3. That is the network layer. At the network, check whether the machine is having the IP address. Well, if it has, okay, verify, is it within the same intended subnet that it should be having that? So if the computer is having the IP address, give it a tick, confirm whether it is within the subnet that was assigned to that. Sometimes the DHCP may fail and it will automatically assign itself an IP address called a PIPA, Automatic Private Internet Protocol address. So that address, even though it has assigned itself, it cannot communicate to the other networks, because with such kind of assignment, there is no default gateway, and default gateway's role is just to locate remote networks or help computers from one network communicate to the other network. So that's what you should understand when it comes to this kind of architecture. So another thing, if a computer here is unable to access a certain server in the demilitarized zone, the first thing, check whether the server is up, the server is reachable by pinging the IP address of that particular server, because servers are always assigned with the static IP addresses because they host shared services. Imagine having an email server whose IP is dynamic. Today is 172.16.30.11, tomorrow is .14. So you are trying to access the service, you cannot be able to send me email because the server is offline or has shifted to a different segment. You see, that's different from a normal user in the local area network. So if you happen to access the service and the service is unavailable, check the status of the server, whether up or down. Is it having the IP address? Is the IP address reachable? 2, sometimes the service might have been moved or deleted. That's where you will get an error, what we call 404, with a code of 404. You can check that. So on the servers, sometimes services are accessed through VPN. Check whether VPN is up. Majority of the organization use what we call remote access VPN with VPN clients. So check whether you can connect to the head office for that. So those are the things as a network engineer, as an IT support, you should be aware of, because errors always happen in normal network environment. Those are the headaches that is the headache among the technicians. So sometimes the internet, for example, this section here and this section might be down. Might be down. Might be down. So if it is down, always check whether the service provider, the internet is reachable. You see, sometimes maybe the provider is having issues connecting you. His router, the network is down. When this link is down here and you don't have any other alternative link in an environment such as this, services here and the data center will be totally down because the feeder is offline. So sometimes check whether you can reach the ISP. If you can reach it, good for you. Now you have the services. So thank you so much for today's lab. I hope you've learned something concerning building real enterprise network in GNS3 using FortiGate firewall, using all these zones. Feel free to subscribe at Netlabs Hub. It's a channel on YouTube dedicated in creating labs and troubleshooting labs as this one, as we move together. Thank you.